Our next topic, Crammers Rule. It was found by Gabriel Cramer in 1750 as his mathematician. He concluded a solution how to find a unique solution when the system of three equations are given. We have already learned in by elementary transformation method. Now Cramer found a different way to find the solution of the given system of linear equations when its coefficient matrix, determinant of its coefficient matrix is non-zero. It is only possible when the determinant value of the coefficient matrix is non-zero. Okay, then what is the method how to proceed it? These are the three different system of equations given in three unknowns. x1, x2, x3 are unknowns, or we can take it as x, y, z. Okay, right, in general form we can take like this: a11 x1, a12 x2, a13 x3 equal to b1, a21 x1, a22 x2, a23 x3 b2, a31 x1, a32 x2 plus a33 x3 equal to b3. There are three system of linear equations in the three different unknowns. These are all constant terms. Now the determinant of coefficient matrix, first we should find a determinant of the coefficient matrix: a11, a21, a31, then a12, a22, a32, a13, a23, a33. Find the value. If it is non-zero, delta, let it be delta. If the delta value is non-zero, we can proceed further. If not, if it is equal to 0, it is impossible. So the Crammers rule is applicable only when delta not equal to 0. That is a one mark question. Crammers rule applicable only if dash. In the answers given that delta equal to 0, delta not equal to 0, like that 4 options will be given. So you should choose delta not equal to 0. The Crammers rule is applicable only when delta not equal to 0. That is, delta is nothing but the determinant of the coefficient matrix. Determinant of the coefficient matrix. Right. That is not equal to 0. We can proceed further. Delta x1. We can find one another delta, that is delta x1. This means the coefficient of x1 replaced by the constant values. The coefficient of x1s all replaced by the respective constant values b1, b2, b3, and the next two columns kept as it is, and then we can find the value of the x1 determinant value, that is taken as x1, and then for one another value delta x2. To find delta x2, the coefficient of x2 are replaced. Coefficient of x2 are replaced by the constant values b1, b2, b3, and the first and the third kept as it is. And then for delta x3, just the coefficient of x3 are replaced by the constants and kept the first two columns as it is in the given question. Right, now we can find the values of determined values of delta x1, delta x2, delta x3. These are all equal to 0 or not equal to 0. You need not to worry about it. They are all equal to 0 or not equal to 0, but delta should be non-zero. Delta not equal to 0. Delta x1, delta x2, delta x3 may or may not be 0. Then in this case, how to find the value of x1, y1, z1? x1, x2, x3 are the unknowns. How to find those values? By Crammers rule, this x1 will be equal to delta x1 divided by delta x2 equal to delta x2. Can write here x2 equal to delta x2 divided by delta, and x3 equal to delta x3 divided by delta. So the solution x1 comma x2 comma x3 will be equal to the values which are arrived in x1, x2 and x3. This is the method to apply Crammers rule. How to working out in the Crammers rule is clear here. Okay, exercise 1.2. Question number 1. Solve by using Crammers rule. The first question is 2x plus 3y equal to 7 and 3x plus 5y equal to 9. By solving Crammers rule, we should find lambda first. How to calculate lambda? Sorry, delta. How to calculate delta? The delta is nothing but the determinant of coefficient matrix. So coefficient matrix is 2, 3, 3, 5. Its determinant value is 2, 3, 3, 5. Calculating determinant value, cross multiply 2 5s are 10, and then cross multiply secondary diagonal 9. Subtracting, we have 10 minus 9 equal to 1, not equal to 0. This means the delta not equal to 0. Crammers rule is applicable. Now we have to find two more values. They are delta x and delta y. To find delta x, replace the coefficient of x in the delta by the constant terms 7 and 9. So these two replaced. Delta x are replaced by constant 7 and 9. Coefficient of x are replaced by constant 7 and 9. The remaining kept as it is 3, 5. Now calculating the value, that is equal to 35 minus 27 equal to 8. Then delta y, that means to find delta y, we can replace the coefficients of y by constants. So 2 and 3 kept as it is, they are coefficient of x. Now coefficient of y are replaced by the constant 7 and 9. Now finding the value, 18 minus 21 equal to minus 3. Here x is equal to delta x by delta, which is equal to 8 by 1 equal to 8. Delta value is 1. And then y equal to delta y by delta, that is equal to minus 3 by 1 equal to minus 3. Therefore solution, x comma y equal to, the value of x is 8, value of y is minus 3. You can substitute these two values in the equation. It will imply the right side value. So you can check yourself by substituting the values. Now question number 2, in that case, second subdivision seems. Now delta equal to determinant of coefficient matrix 5, 3, 3, 7, and simplifying, we will get 35 minus 9, which is equal to 35 minus 9, which is equal to 24. Now the second question, here delta equal to 5, 3, 3, 7 will be equal to 35 minus 9, that is equal to 26, and delta x is equal to 17, 31. Replacing the coefficient of x by constant 17 and 31 and keeping y as same, coefficient of y as same. Now finding the determinant value, 17 into 7 minus 31 into 3, which will be equal to 26. Now delta y, to find delta y, replace the coefficient of y by constant. So the coefficient of y is replaced by 17 and 31. So 17, 31, finding delta y, 5 into 31, 155, minus 3 into 17, 51. Subtracting, we have 104. Now we can go to for value of x and y, where x is equal to delta x by delta, that is equal to 26 by 26 is equal to 1, and delta y equal to delta y by delta, that is equal to 104 by 26, that is equal to 4. Therefore the solutions x and y are equal to 1 comma 4. Substituting the values of x and y in the system of given system of equations, you can verify the answer yourself. Now you can add here is not equal to 0, delta not equal to 0. Therefore Crammers rule is applicable. Therefore Crammers rule is applicable, we can add. Okay. Next question in the Crammers rule. Solve by using Crammers rule. 2x plus y minus z equal to 3, x plus y plus z equal to 1, x minus 2y minus 3 is equal to 4 is given. Three system of equations with the three unknowns is given. So we should find delta, which should be not equal to 0. Then should find delta x, delta y, delta z. Then finally we can find x, y, z by using the formula x is equal to delta x by delta, y equal to delta y by delta, and z equal to delta z by delta. Okay, how to find delta? Delta is nothing but determinant of coefficient matrix 2, 1, minus 1 first row, 1, 1, 1 second row, 1, minus 2, minus 3 in the third row. Finding determinant value, we are all familiar when in the exercise 1.1 We did many problems in the determinant method. Now determinant of 3 by 3, 2 into minus 3 plus 2. While cross multiplying the secondary diagonal, we should change the sign. Now principal diagonal minus 3, secondary diagonal minus 2 means it will become plus 2. Then here taking this entry, because of the cofactor, it changes its sign. So minus 1 into, then this 1 appears in the second column and first row. Taken these 4 elements to find its value, then minus 3, then cross multiply, it is 1, so minus 1, because the secondary diagonal, when multiply the secondary diagonal, you should change the sign. So this is minus 1 because of the cofactor value, and then taking these 4 values, 3 minus 1, then minus 1 into, taken these 4 elements to calculate the determinant value, then minus 2 minus 1. Okay, simplify, we have 2 into minus 1, minus 1 into minus 4, minus 1 into minus 3. Multiply minus 2 plus 4 plus 3, which will be equal to 5, not equal to 0. Therefore, Crammers rule is applicable. Then the next move is to find delta x. Delta x is equal to, how to find delta x? Replacing the coefficient of x in delta by the constant values 3, 1, 4. So the coefficient of x is replaced, and then the constant values are applied here 3, 1, 4. The remaining two entries are same. Two columns are appeared as it is 1, 1, minus 2, minus 1, 1, minus 3. Now expanding this with respect to R1, 3 into, taken this 3 into minus 3 plus 2. Then this one changes its sign, minus 1 into, here minus 3 minus 4, then this minus 1 into minus 2 minus 4. Simplify, we have 3 into minus 1, minus 1 into minus 7, minus 1 into minus 6, that is equal to minus 3 plus 7 plus 6. Then totally we have 13 minus 3, 10. Similar to that, delta y will be equal to minus 5 and delta z is equal to 0. Continuing the same way, you can find delta y minus 5 and delta z is 0. Now delta non-zero, by using Crammers rule, we can find the value of x, y, z. X is equal to delta x by delta, that is equal to, what is the delta x? 10 divided by delta is 5, that is equal to 2. Then y equal to delta y by delta, that is equal to, the value of delta y is minus 5 divided by delta is plus 5, that is equal to minus 1. And z equal to delta z by delta, that is equal to 0 by 5 equal to 0. Therefore, the solution x comma y comma z equal to 2 comma minus 1 comma 0. This is a very easy method to calculate. This type of problem will be asked in 5 mark. Exercise 1.2, subdivision number 6, subdivision number 5. Now we have one another question solved by using Crammers rule. X plus 4y plus 3z equal to 2, 2x minus 6y plus 6z equal to minus 3, 5x minus 2y plus 3 is equal to 3z equal to minus 5. Given solved by using Crammers rule, first we have to find delta, then delta x, delta y, delta z. To find delta, take the coefficients of the given equations of x, y, z. Then delta is nothing but the determinant value of the coefficient matrix. In the first row we have 1, 4, 3. 1, 4, 3. In the second row we have 2 minus 6, 6. In the third row we have 5 minus 2, 3. 5 minus 2, 3. Now expanding this, 1 into minus 18 plus 12. Then this one is gets changed, sign change, minus 4 into 6 minus 30. Then 3 for 3, minus 4 plus 30. Simplify, we have minus 6 minus 24 plus 26. Multiplying this, we have minus 6 plus 96 plus 78, which will be equal to 168, not equal to 0. Delta not equal to 0. Therefore, Crammers rule is applicable. Crammers rule is applicable. Then find delta x. To find delta x, replace the coefficient of x by the constant values 2, minus 3, minus 5. That is replaced by the constant values. Coefficient of x replaced by constant values, and then other values kept as it is. So minus 4, minus 6, minus 2, 3, 6, 3. Expanding this in the similar way above as a delta. Now 2 into minus 18 plus 12, then minus 4 into minus 9 plus 30, then 3 into 6 minus 30, which will be equal to 2 into minus 6 minus 4 into 21, then plus 3 into minus 24. Multiply and simplify, will get minus 168 again. Here plus 168, here minus 168. And delta y equal to, replace the coefficient of y in delta by its constant values 2, minus 3, minus 5. So there no change in the first column, and the second column values are changed by the constant values 2, minus 3, minus 5. Then no change in the third column. Then expanding again, 1 into minus 9 plus 30, then minus 2 into, always taking this value, change the sign, minus 2 into 6 minus 30, and then 3 into minus 10 plus 15. Minus 10 plus 15. Simplify this, 21, 1 into 21, minus 2 into minus 24, 3 into 5. Then it will be equal to 21. Multiplying these two, 48, here 15. Totally we have 84 as delta y. Then delta z, similar way you can proceed. The delta z will be equal to 56. So by Crammers rule we can find the value of xyz by Crammers rule. X is equal to delta x by delta, that is equal to, the value of delta x is minus 168 divided by delta value 168 equal to minus 1, and y equal to delta y by delta, that is equal to, the delta y value is 84 and divided by 168, that is equal to 2, 1 by 2. Then z equal to delta z by delta, that is equal to 56 divided by 168, that is equal to and z equal to 1 by 3. Therefore solution x comma y comma z equal to minus 1 comma 1 by 2 comma 1 by 3. Minus 1 comma 1 by 2 comma 1 by 3.